Okay, so one of the very last things we do in the thermochem unit is talk about activation energy and catalysts. So here's an example we do in class. So the first thing is you're given an activation energy of the forward reaction, and that just means the energy you're putting in to make the reaction happen. But this part here, the delta H of the reaction, that still gives us a lot of information. We know that if it's positive, it's going to be endothermic. And before, when we were looking at potential energy diagrams, if it was endothermic, it would look something like this. Your reactants are lower than your products. So we're still going to have that, the reactants line and the products line, and this distance in between is still going to show us delta H. What we're going to add on is that activation energy, the energy you're putting into the reaction. So from your reactants to the top of a hill, that is the distance from here to here. So reactants to the top of the hill, that's your activation energy. So that distance, that EA, would equal the 334 kilojoules. Then the distance from your reactants to your products, this is a P. Your reactants to your products, this distance here, that is still showing your delta H that we learned from before. So that would be 226 kilojoules. Now, the only thing you can add on here that this question is not asking you for, but is your reverse energy or activation energy. So that is going to be from the products to the top of the hill. So this distance here, that would be your activation energy of the reverse reaction. And to get that, if we know that our whole distance is 334 and part of that distance is 226, and we subtract it quickly, so 334 minus 226, you get 108. So if we approach this from the other direction, from the products going to reactants, you'd have to put in 108 kilojoules to make that reaction happen. So to summarize here, always, whether it is endo or exo, your reactants to the top of the hill will equal your activation energy of the forward reaction. Products to the top of the hill will equal your activation energy of the reverse reaction. And then the distance between your reactants to products will always be your delta H. And as we should already know, if your reactants are lower than your products, it's endo. And if your reactants are higher up than your products, it is an exothermic reaction, and your value for delta H should be negative. I hope that's helpful. Oh, and just to add on, if you did have a catalyst, all a catalyst does is bring down that activation energy in terms of the hill. So it makes that reaction happen faster. So if we had a catalyzed reaction here, we would just have another pathway for that reaction to take, and it would be a quicker pathway. And we know that because that hill is not as big. We don't have quite a big hill to get over. I hope that is helpful. And if you have any questions or would like me to do any other videos, please let me know. Thank you. Oops.